Hi everyone. We're going to take a look at one of the new AP topics as a worksheet. This one deals with sandwich theorem. And you'll remember from our discussion earlier this year when we were talking about limits, we said that imagine you've got this function f of x, and this function is continuous. Well, actually, I want to give you three functions. I want to say f of x and g of x and h of x are all continuous. And I want f of x to be some function that's always either between or equal to h of x on one end and g of x on the other. So what we know is if g at some point equals h at some point, then f at that point will have the same value. The other thing I want to remind you about is the notion that if I want to know what f of a is, for example, I can't just do the limit as x approaches a of f of x, right? Because that's this situation. Even if you tell me f of a exists, for continuity reasons, f of a could be here, and the limit certainly exists because we're approaching the same y value from both sides of x equals a. So in order to be continuous at a point, remember we need f of a to equal that limit as x approaches a of f of x. Okay, so if we can show the limits are the same, and we can show that g and h are equal, then we know that f at that point will also have the same value. All right, well, let's take a look now with this confusing stuff in mind, which really shouldn't be that confusing, at one of these questions. It says that g and h are defined in this way. This is question number 1. G of x equals negative 2x squared plus 4x plus 1. And h of x equals 1/2 x squared minus x plus 11 halves. And then the directions go on to say f is a function that satisfies g is less than or equal to f is less than or equal to h. That's classic sandwich theorem setup. For all x, then they ask, what is the limit as x approaches 1 of f of x? Well, we know the limit of x approaches 1 of f of x will be the same as x approaches 1 of f of x is going to be equal to, because all of these things are continuous, f of 1. And f of 1, because of the sandwich theorem, has to be between g of 1 and h of 1. So all we really need to do is find g of 1. Let's do that in a different color so it stands out a little better. G of 1 will be negative 2 times 1 squared plus 4 times 1 plus 1, which will be 5 minus 2, or 3. And if we find h of 1, that's 1/2 1 squared minus 1 plus 5/2. Okay, so 5/2 plus 5/2 plus 1/2 is 6/2, or 12 halves, so that's 6. 5/2 plus 1/2 is 6, minus 1 is 5. Okay, so somewhere I made a mistake because, these are supposed to be equal to each other. 11 halves, that's true. And we want the limit as x approaches 1. So, no, really, the limit and the function are supposed to be the same. 2, 5 minus 2, yes. And 1 half, and that's a positive 1 half. It's always good to check you copied down the problem correctly. 11 halves, 6 minus 1 is 5. And I really want this to be 5 too, but it keeps turning out to be 3. So let's try it again. 5 minus 2. Yeah, that's a thing. Huh. Well, what was I thinking? Oh, I know what I was thinking. Look at this relationship. We know that g of 1 is smaller than f of 1, which is smaller than h of 1, and we know that g of 1 is 3, and h of 1 is 5, so we know that f of 1 has to be between 3 and 5, which means the limit as x approaches 1 has to be between 3 and 5. So this is a multiple choice problem, and our choices are A, 3, B, 4, C, 5, and D, the limit cannot be determined. Well, here's the thing. I think the limit cannot be determined. Because it could be equal to 3, it could certainly be 4, and it could certainly be 5. We don't have enough information here. Sorry I was going momentarily crazy there, because I was expecting to get the same number here, and therefore I would know that f of 1 would be that same number. But here they're just setting me up to say, well, no, you can't actually tell what the value of that limit will be. All right, so the first one is D. Let's take a look at the second one. The second one, g and h are functions defined by g of x equals sine pi over 2x plus 2, close 2 parentheses, plus 3, and h of x is defined in this way, negative 1/4 x to the third minus 3/2 x squared minus 9/4 x plus 3. And that f is a function that satisfies g is less than or equal to f is less than or equal to h for negative 2 to 0. What is the limit? Negative 2 to 0. Oh, what is the limit as x approaches negative 1 of f of x? Okay, so let's try this one the same way and say that, well, this limit is going to equal this value, and this value, according to this relationship, g of negative 1 is less than or equal to f of negative 1, which is less than or equal to h of negative 1. And when I plug a negative 1 into each of these values, what do I get? Well, negative 1 plus 2 is 1, pi over 2. Sine of pi over 2 is 1. 1 plus 3 is 4. So I get a 4 over here. And if I plug a negative 1 in here, I get negative 1/4 minus 3/2 minus 9/4 plus 3. So that's 10/4 minus 10/4 minus 6/4. That's minus 16/4, which is minus 4. Oh, sorry, it's a cubing function, and I'm plugging in a negative. Minus, 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 I'm going with plus. Minus squared, positive, but that's times that negative. Minus, minus is plus. Okay, so let's try that again. We get 10/4 minus 6/4 fourths plus 12 fourths, which is 16 fourths, or 4. Okay, and so we get a 4 over here. And so we know that f of 1, or f of negative 1, has to be squeezed in between 4 and negative 4, and therefore the limit as x approaches negative 1 of f of x is equal to that f of negative 1, and so we say that that limit is equal to 4. And that is choice C. C for number 2. Okay, let's take a look at 3. 3 over here on the side. 3 says same thing, except now g of x equals sine pi over 2x plus 4, and h of x equals negative 1/4 x to the third plus 3/4 x plus 9/2. And this time they say, hey, what's the limit as x approaches 1 of f of x? And they tell us that g is less than or equal to f is less than or equal to h. Okay, so I know that the limit as f approaches, the limit of f as x approaches 1 will be the same as f of 1, and f of 1 must be squeezed in between h of 1 and g of 1. So let's find g of 1. 1 times pi over 2 is pi over 2. Sine of pi over 2 is 1. 1 plus 4 is 5. And if we plug a 1 into h, we get negative 1/4 plus 3/4 plus 18/4. So 21/4 minus 1/4 is 20/4, or 5. And so f of 1 must be between 5 and 5. Therefore, f of 1 is 5, and therefore the limit as x approaches 1 of f of x is going to be 5. And this is choice C as well. Okay, problem number 4, our last sandwich theorem problem. This time we have f is defined as sine x over 2x, and g is defined as x to the 4th cosine 1 over x squared, and h is defined as x squared over 10x for x not equal to 0. We are on the interval negative 1 to 1. Which of these inequalities can be used with the squeeze theorem, which is a synonym for sandwich theorem, to find the limit of the function as x approaches 0, because they tell us here x can't equal 0 because of all these things. Okay, so, well, we know that these functions are, well, I guess in this problem I'd kind of want to, if it was free response, I'd want to say something about these functions being continuous everywhere except here. But really, they just want me to find the limit of the function. So let's think about the limits of the functions here. You know, we've been saying all along that g is less than or equal to f, which is less than or equal to h, and that's pretty much our standard. Let's plug in as x approaches 0. So we want the limit as x approaches 0 of g of x, and in this situation, if I plug in a 0, I get 0 times cosine infinity, and that makes me feel sad. So, so in this situation, I remember that we said, hey, the limit as x approaches 0 of x to the fourth times cosine 1 over x squared if I plug zeros in, I get 0 times cosine 1 over 0 infinity. Okay, so sad face. That's the limit for g. What about the limit for f as x approaches 0? That would be the limit as x approaches 0 of sine of 0 over 2 times 0, which is 0 over 0. Aha! I need L'Hopital's rule here. So with L'Hopital's rule, the limit would now be derivative of the top, cosine, derivative of the bottom, 2, plug in a 0, cosine of 0 is 1, and I get 1/2. And then, if we look at the limit of h as x approaches 0, that limit would be 0 squared over tangent 0, which is 0 over 0, so we need to use L'Hopital's rule. And that would then give me the limit as x approaches 0 of the derivative on top, 2x, the derivative of tangent is secant squared x. Okay, so secant squared is the same as 1 over cosine squared, so I'm going to write this. Well, am I going to write this? No, I'm not going to write this, because I know that the secant of 0 is the same as the cosine of 0, and that's 1, and I get 0 over 1, which is 0. So I've got 1/2, I've got 0, and I've got sad face. I've got 1/2, I've got 0, and I've got sad face. So what can I say here? Let's see, and this was g of x approaches 0 of g. This one seems to need to be a thing. And I feel like I can squeeze my g of x in between these two things that I know, but these two things aren't equal. Though I could certainly say that f is bigger than h at that point. And so I sort of feel like I want to say, let's put the let's see. All of these cases are L'Hopital's cases. Well, except this one feels, I don't know what I'm supposed to do with that, because that feels like a constant times 0, which is 0. The value of these limits. I really want these limits to be the same. All right, so let's take a second look with L'Hopital's rule. If I use L'Hopital's rule here, the derivative of sine is cosine, the derivative of 2x is 2, I plug in a 0, I get 1/2. And here, if I do the derivative of x squared, yes. I do the derivative of tangent, yes. I get 0. Okay, so that's correct. And what about this one? Well, cosine cosine of 1 over x squared. 1 over 0 is undefined, is infinity. That's a number between -1 and 1 times 0, which feels a lot like a 0 to me. Wow. I'm going to have to go back and do some more research on this problem. I'm sorry. I have here that the answer is B, but I'm going to have to get back to you on why the answer is 2 only. B, 2 only. Which of these inequalities? Negative x to the 4th, g is between that and x to the 4th. Well, wait a second, because I know here that this is a number between -1 and 1. And I know that this number for f is bigger than this number for h. And if I multiply -1 times x to the 4th, I get negative x to the 4th. And if I plug in 1 times x to the 4th, I get x to the 4th. And so this makes a lot of sense to me, that g of x is between negative x to the 4th and x to the 4th at 0. So I feel like I can certainly say that for dealing with this sad face. Oh, maybe I didn't need to do a lot of this. Oh, I guess I did need to check the others. So with the others, I don't need to worry about them because I can find the limits. Let's take a look at these other choices up close. And if we plug in -1 into f, no, I'm not plugging -1 into f. If we, yeah, Zoff. So f has got to be squeezed in between. Nope. I can tell you why 2 works, but I can't tell you why I'm not interested in f and h, because I have limits for those. I'll get back to you on this. All right, well, let's wrap up this travesty right here and move on to the next one.